Have you ever found yourself just looking at a leaf, maybe on a walk, and wondered why no two are ever really exactly identical, even from the same tree, the same branch?
Or maybe you've noticed how certain patterns just keep showing up everywhere, like spirals or hexagons.
Exactly. You see them in flowers, beehives, even way out in spiral galaxies. It makes you wonder.
It does. It suggests there's some kind of underlying, well, blueprint, maybe.
Yeah.
A hidden order to things.
Absolutely. And that's what we're getting into today on the deep dive. We're exploring a really revolutionary new framework. It's not just a small adjustment to how we see things.
No, it's a pretty fundamental shift.
It suggests the universe isn't really built on stuff, matter and energy as we usually think of them. Instead, it proposes reality is all about, well, folded time.
Folded time. It sounds intriguing. And this leads to a concept called a time fraction engine.
Right. And this engine supposedly explains not just those patterns we see, but it also makes some really fresh, startling predictions. Predictions that are crucially falsifiable.
What?
Testable.
Which is key for any scientific idea.
Exactly. It could genuinely, as the sources say, rewrite the universe at scale.
So today, we're diving into some cutting-edge ideas, mainly from papers like a time fraction engine for universal geometry and geometry of time's fold, a universal framework.
We'll try to unpack the core concepts, look at the math without getting too bogged down, see how it connects to big questions like consciousness,
And quantum mechanics.
and then lay out those concrete, testable predictions. So yeah, get ready to maybe challenge some of your basic assumptions about how reality works.
It sounds like quite a journey. Where do we start?
Let's kick off with Section 1, the universe as a symphony of time's folds. The first big idea is this radical shift away from thinking of energy as, well, as a substance.
Yeah, we usually think of energy like a fluid, something that flows or gets stored.
Yeah.
But this framework says, hold on, maybe energy's fundamentally measurable tension between phases.
Tension between phases. Okay, what does that actually mean? Like a stretched rubber band?
That's a good analogy. The energy isn't the rubber itself, but the tension in it, the difference between stretched and relaxed. It's about the difference, the gradient.
Okay. And this leads to a core concept. The time phase field, they call it theta.
Right. So imagine our usual reality, 3 dimensions of space, 1 of time. That's our 4D manifold down.
Standard stuff, yeah.
Now, picture overlaying this entire manifold with an extra field, a scalar field called theta. This field isn't just math. It supposedly encodes the local state of a universal cycle.
A universal cycle, like a cosmic heartbeat.
Sort of. Think of it like the entire universe having an underlying rhythm, and theta tells you at any point in space-time exactly where you are in that cycle, that beat.
Okay, I'm with you so far. But then comes the folding part. You said this isn't just a metaphor.
Apparently not. The sources suggest it's literal folding within this theta field. And when theta does something specific, like locking into simple fractions...
Like,
Exactly, those simple rational phase locks. When theta hits those, it creates these incredibly stable structures, cuts, or symmetry rails, they call them.
symmetry rails. Like stable notes in music. Harmonies.
That's a perfect way to think about it. These are the points of stability, coherence, the patterns that naturally persist.
Okay, so those are the stable beats.
Mm-hmm.
But what happens when theta doesn't lock into those simple fractions?
Then you get the irrational rotations. These don't settle down. They don't repeat perfectly.
So keep going.
They spread. And often they spread into these beautiful golden class patterns. Think Fibonacci spirals and sunflowers, or those galaxy arms. It's like a melody that's always flowing, always changing, generating novelty.
Interesting. So you have stability from the rationals and novelty or spread from the irrationals. How does the universe use this?
That brings us to the next piece, the fractional geometry factor, a phi of theta. You can think of this as a kind of multiplier or amplifier built into the fabric of reality.
A multiplier. What's it
Yeah.
multiplying?
It multiplies the effect of geometry on energy. What's fascinating is how it behaves.
Mm-hmm.
Apparently it changes suddenly when theta hits one of those rational locks, PQ. That's what creates the strong symmetry rail.
Okay.
But when theta is drifting along an irrational path, it changes smoothly. No sudden jumps.
So this phi factor is like a switch or maybe a dimmer. What does it control?
The sources call it the lever in the universe. It dictates how geometry itself can amplify or multiply the energy yield and stability of a system.
Wait, so geometry isn't just a passive container. It actually does something to the energy.
That's the core idea. The shape isn't just holding the energy. The shape itself, through this factor influences how much usable energy you get out or how stable that energy configuration is.
That's pretty different. How does that fit with physics, like Lagrangians and energy density?
Well, they use those concepts. The equations for the Lagrangian L and energy density include terms involving theta and, crucially, this factor. For instance, the energy density involves terms like the square of the gradient of theta, which represents that phase tension we talked about.
Right, the difference.
And that tension is then scaled or multiplied by the geometry factor.
So energy is phase tension scaled by geometry.
That's the essence of it. It's not stuff. It's tension shaped and amplified by geometric structure derived from time's folds.
How does this change something fundamental like EMCUR?
It offers a reinterpretation. The sources propose E or EUI is equivalent to MC throw times an average value of this phi factor, E.
E equals MC foo times phi.
Yes. And matter itself corresponds to trapped phase regions, where theta is sort of wound up, and its gradient energy, its tension, is held stable by boundaries.
Which implies what?
It implies that if you have the same mass, but different geometry, you could have a different EA.
Wow. So the geometry isn't just holding the mass energy, it's multiplying its effective yield or stability.
Precisely. Geometry becomes an active player, not just a stage. Imagine tuning the geometry of a fuel source to get more usable energy out without adding more fuel. That's the lever.
That's a huge implication for energy tech, material science, everything really. Okay, so if time folds create energy and geometry influences it, what about gravity? And how do shapes actually get made? Let's move to section 2. Gravity as a shadow, shapes as renders.
This part is really elegant. The framework suggests gravity isn't fundamental. It's not a force pulling things together in the usual sense.
It's not. Then what is it?
It emerges. It's described as the 3D shadow of the 4D phase geometry we've been talking about.
A shadow, like Plato's cave.
A bit like that, yeah. Imagine a complex 4D object casting a shadow onto our 3D space. The shadow would look curved, distorted. Gravity in this view is that curvature, that distortion. It's a consequence of time folding in higher dimensions, showing up as spatial curvature in ours.
So Einstein's equations still work, but they get augmented.
Essentially, yes. The Einstein field equations get additional terms involving this time phase field, theta, and its multiplier feed.
And what do these extra terms do?
The key thing is, when theta is smooth, when time isn't really folding significantly, these extra curvature terms basically disappear. Space-time looks flat, like we expect an empty space far from mass.
But when time folds?
When theta folds, when you get those gradients, those phase differences, bam, those terms kick in and they curve space-time. Gravity becomes a direct, unavoidable consequence of time folding itself.
So gravity is the universe bending around these temporal patterns. Okay. Then how do specific shapes form? How does a snowflake get its hexagonal symmetry? Or a shell its spiral?
That brings us to the universal renderer. The idea is there's a sort of universal process for building form. They use a concept called a morphogen order parameter. Let's just call it psi.
Psi the sculptor.
You can think of it that way. Psi represents the local state of whatever's developing, tissue, crystal, whatever. There's an evolution equation for psi. But the core idea is simple. Psi tries to settle into stable geometric forms.
And what tells it which form to settle into?
Theta. The time phase field sets the available symmetries.
Ah, so the fractions come back in.
Exactly. Remember those rational locks? A half lock, the simplest fold, tends to produce polarity like a top and bottom, or simple binary structures, maybe even diamond-like forms.
Okay.
A Orlock, that stable third, drives towards hexagonal structures, honeycombs, basalt columns, maybe even that weird hexagon on Saturn.
And time.
That fifth drives towards decagonal shapes, or more commonly, those beautiful spiral forms, the feed-based patterns.
Yeah, so like DNA sets the menu of ingredients, the proteins and stuff.
Right, DNA provides the machinery, the building block.
But the local time phase field, theta, tells the system which symmetry to build with, like choosing a template.
Precisely. The local theta sets the symmetry attractor, and then psi, the developing tissue or structure, falls into that attractor. It renders the form based on the available symmetry dictated by the time folds. It's like the universe has a built-in graphics engine.
That connects the abstract folds to actual shapes. How does this work across different scales, from tiny cycles to big structures?
That's the scale bridge. Imagine a point moving around a cycle. The angle it advances each step, let's call it alpha, determines the pattern it traces out.
Okay.
If you map these points onto a 3D sphere, you get patterns like leaves on an orb. If you map them to a 4D hypersphere, you get fields across 4D. The math involves things like Kronecker sequences and the Hopf map.
Right, but the core idea is the angle alpha.
Yes. If alpha is a golden class irrational number, like related to the golden ratio, you get those near uniform, non-repeating patterns. Maximum spread, minimal overlap, like Fibonacci spirals. Nature uses this for efficiency, creating novelty.
And if alpha is a simple fraction, PQ.
Then the points line up. They condense onto Q distinct symmetry rails. This creates closure, stability, repeating patterns, like crystals.
And the leap is replacing that fixed angle alpha with the dynamic, space-time varying theta field.
Exactly. When you do that, you get both regime spread and novelty versus rails and stability playing out everywhere, all the time, across all scales, from quantum fields to galactic structures. These fractional dynamics are the fundamental architects.
Incredible. It makes the universe seem so interconnected and alive. Let's bring this right down to Earth, literally. Section 3, Nature's Blueprint, Why Every Leaf is a Unique Song.
Okay, yeah, back to the leaf. If DNA was a rigid blueprint, like an architectural drawing,
Every oak leaf would be identical, like stamped parts.
but they're not. You can see it yourself. Each one is unique, even on the same twig. That simple fact tells us DNA isn't the complete story for shape.
So DNA doesn't have the coordinates for every cell, every vein.
No. It provides the machinery. It says, build chlorophyll here, make cellulose, use this type of cell. It provides the toolkit, the basic instructions.
But not the final exact layout.
Right. The sources argue that the real code for the leaf's unique shape comes from time fractions and fields. A leaf grows in a really dynamic environment.
You mean like sunlight cycles?
Sunlight cycles act like time packets, plus water pulses, bioelectric fields within the plant tissue itself, even tiny variations in gravity. It's a complex, oscillating field environment.
And these different cycles
Ninja.
interfere.
They fold and interfere, creating localized time fractions. And these fractions create nodes, or points of stability, in the morphogenetic field, guiding the leaf's growth.
Growth attractors.
Exactly. Think of them as little whirlpools in an energy field that pull the growth towards them. The final outline of the leaf, its unique shape, is basically the visible trace of where these nodes stabilized. It's a frozen interference pattern.
So that's why they're all unique. The field conditions are never perfectly identical.
Never. Tiny shifts in light angle, microgravity, charge distribution, even how water molecules are clustering nearby. That subtly shift the phase of those time fractions,
And a phase shift means a slightly different pattern of attractors.
leading to slightly different boundary conditions for growth, and thus slightly different geometry. It's like opening the same file on two monitors with slightly different settings. Same code, DNA, unique rendering, leaf shape.
That makes intuitive sense. Can we see these fingerprints of time folding more directly, like in the veins?
Definitely. Leafination isn't random scribbling. Veins form to distribute nutrients efficiently, and the patterns follow these fraction laws.
How so?
Well, that occlusion tendency we talk about, it often leads to hexagonal tiling in the vein meshes. You can see patterns that look remarkably like honeycombs if you look closely.
Wow. And the O fraction.
That leads to spirals. You see it in how secondary veins branch off, or how lobes might spiral outwards. The vein map is literally a snapshot of the interference patterns.
What about how leaves are arranged on the stem? Phyllotaxis.
Classic example. Leaves spiral up, right?
Yeah.
Rarely opposite each other. The common angle is about 137.5 degrees, the golden angle,
Which relates to the O fraction. Why that angle?
because it never repeats. It ensures minimal overlap, maximizing how much sunlight each leaf gets. The plant is using time fractions to solve an optimization problem.
And tree branching.
Same idea. Trees are fractals. The trunk is like the main cycle. Branches split off at angles, often related to Ferriction's stable points of division. Each branch is like a new fold of time propagating out into space.
So the apparent weirdness or randomness isn't random?
It's sensitivity. Sensitivity to the local field conditions operating within a universal law. The law is constant. The local rendering shifts.
Okay, one more leaf question. Why are some leaves smooth and roundish while others are sharp and spiky? Is that also fractions?
The framework suggests yes. It's not arbitrary. The fractions create a range of attractors.
So tending towards closure?
Often leads to rounder margins, seeking that stable hex-like closure.
But if you add other fractions?
If you overlay higher fractions, maybe a bit of half-air or five-rail pattern on top of the ogo, they create extra standing nodes. These nodes can sort of pinch or focus growth, leading to sharp lobes or serrated edges.
Same DNA, different local fields, selecting different attractors. Amazing. It connects the micro to the macro beautifully. Okay, let's scale up again. Section 4. Consciousness, the vacuum, and something from nothing. Big topics.
Definitely. Let's tackle that something of nothing paradox first. This framework suggests nothing wasn't ever truly empty in the sense of a void.
What was it then?
Smooth time. Undivided potential. Like white light before a prism, it contains all the colors, but they aren't separated yet. It's pure potential, undifferentiated.
Okay, so potential exists. How does something arise?
The moment smooth time folds, the instant there's a ripple, a difference within it. Crest versus trough, phase here versus phase there.
That creates difference.
Measurable difference, and that measurable difference, that tension, is energy.
Energy isn't stuff, it's difference.
Exactly, and when that energy, that difference, gets trapped by a stable boundary created by more folds, it becomes form, matter.
So the sequence is potential A-fold, difference, energy, a geometry boundary, form.
That's the proposed chain of emergence. No magic, just unfolding potential.
Now, consciousness, that often feels like the hardest problem. How does this framework approach it?
It offers a surprisingly precise definition. Consciousness as self-reference.
Self-reference, like looking in a mirror.
More dynamic than that. Yeah. It's when a system becomes self-referential, both inside and outside simultaneously. Imagine a feedback loop, where a system doesn't just react to the world, but constantly senses its own internal state, processes that information, and modifies its behavior based on that self-sensing.
A recursive loop.
Exactly. This internal feedback loop, this constant folding back on itself, is a fold. And crucially, this self-folding can generate its own internal difference, its own energy, without needing constant external input once it gets going. It becomes self-sustaining.
So consciousness is a kind of self-sustaining pattern, a resonance.
A resonance attractor that generates internal difference from within. It's a system that keeps itself going by continuously observing and reacting to its own state.
What does that predict? Could we build conscious AI this way?
That's the direct prediction. Any system, biological or artificial, complex enough to recursively reference its own state across multiple scales should exhibit conscious-like behavior, because it will naturally trap time into these self-sustaining energy loops, creating a persistent internal self.
So consciousness isn't a ghost in the machine, it's an emergent property of this kind of complex, self-referential architecture.
That's the idea. It becomes potentially engineerable based on understanding these phase dynamics.
This leads to a really profound, almost poetic idea in the sources. We are the empty space inside the boundaries. What does that mean for us personally?
Well, remember, boundless smooth time. That's the infinite undivided potential.
Right.
When time folds, it creates fractions, which create boundaries, the edges of things, the walls of atoms, cells, bodies.
Okay.
These boundaries carve out reality, creating an inside versus an outside. And the inside, that is space. Our bodies, trees, galaxies, they're compartments carved into boundless time by these resonant boundaries.
Pockets of differentiated time.
Exactly. And what we call matter is essentially the stuff forming the wall of the boundary, the trapped energy.
Yeah.
But what we experience is self. This framework suggests it's the empty space held inside those walls.
Empty space, but
Yeah.
that sounds like nothing.
Not empty like a void. It's dynamic, it's oscillating, it's coherent. It's that boundless time field, full of potential, just shaped into a localized pocket by the boundaries. It's where the self-reference happens.
So we're not just the physical boundary, we're the dynamic potential held within it. Wow, okay. That's a lot to chew on. Let's move to section 5, which ties it all together beautifully. The universe's score harmony in every form. The music analogy.
Yes, this really helps make it intuitive. Music is almost a perfect metaphor.
So, the starting point.
The one input, smooth time. Think of it like a single steady vibration, maybe a pure tone fed into a speaker. All potential, no structure yet.
Then the folding starts.
Folding in fractions, notes and harmonics. A guitar string physically folds into halves, thirds, fifths. Those are its harmonics, its notes. Smooth time folds into half, Euler creating polarity, hex patterns, spirals. These are the universe's fundamental notes.
Okay, and the boundaries.
Boundaries, the instrument body. A violin's body isn't just a box. It shapes the string's vibrations into the rich sound we hear. Universal boundaries, atoms, DNA, water structures, planets they filter and shape time's fractions into the forms we see.
The instrument shapes the sound. And energy.
Energy as difference, sound versus silence. Music needs dynamics, tension, and release. Energy is that measurable difference between time folds, the tension. Without difference, there's no energy, no sound, just silence.
And gravity.
Gravity, acoustics of space-time. Just like the acoustics of a room shape how sound travels and resonates, gravity is the curvature that takes the 4D time folding and stabilizes it into 3D form. It lets the music take physical shape.
Which leaves life.
Life, the song. Life isn't static, it's the ongoing performance. Fractions woven into harmonies, layered into complex symphonies. Every living thing is a unique rendition, a unique performance of the same underlying universal score.
That's why music affects us so deeply, maybe. It resonates with the fundamental structure of reality
It
itself.
seems plausible. We could even map specific fractions to musical intervals and natural forms.
Like half.
That's polarity, like the octave in music. The most basic stable division, root versus shoot, head versus tail, binary systems, fundamental stability.
Hmm.
That's closure, like the perfect fifth.
Yeah.
Foundational harmony manifests as stable closures. Hexagonal meshes, basalt columns, maybe even that Saturn hexagon, nature's structural consonants.
Mhm.
Stability again, the perfect fourth, leads to repeating tiles, squares, crystal lattices, orderly structure.
And the big one?
That's the spiral, the golden ratio, novelty.
Yeah.
Musically, like the major third, ratio's dynamism, emotion. In nature, it forces spirals because it never tiles perfectly.
Mm.
Sunflowers, DNA, galaxies, the engine of growth and complexity.
What about more complex fractions?
Higher fractions create more complex musical ratios, Kenshin, like sevenths, ninths. In nature, they lead to intricate forms, lobed leaves, fractal branches, asymmetry, individuality. The complex flourishes.
So the distilled law is the harmony in music is the harmony in nature. Dissonance is tension, resolution is stability. It's all one system.
That's the compelling argument. It's
Yeah.
all variations on a theme played out by times fractions.
Okay, this is inspiring, but now for the crucial part. Section 6. The universe is rewriting concrete predictions and deep math for skeptics. This is where the rubber meets the road. What does this framework say cannot happen?
Right, the logical exclusions. These are critical for testing. First, no energy is stuff. You
Yeah.
can't just treat energy like a substance you pour around. It's phase tension. It needs the right geometry to even exist stably. Experiments ignoring geometry's role will miss the point. No DNA determinism of form. Identical DNA cannot produce identical shapes if the field conditions, the local theta environment, change. If shape only follows DNA regardless of the surrounding phase field, the theory's wrong.
Third.
No purely local morphogenesis. Simple chemical gradients spreading locally can't explain large-scale coherent symmetries like a whole hexagonal organ or a perfect spiral across a shell. There has to be a non-local field-level influence based on these fractions. If blocking non-local phase coherence doesn't affect the overall shape, the theory fails.
Fourth, the quantum connection.
No random collapse at quantum scale. Quantum collapse isn't truly random noise. It must correlate with the geometry of the boundaries, which impose specific fractional cuts on the possibilities. If collapse statistics are identical in, say, half versus symmetric cavities at constant energy, the theory's link to quantum mechanics is broken.
Fifth.
No gravity-first ontology. Gravity doesn't come first. It emerges from already folded time. You can't have gravity without the underlying phase geometry causing it.
Sixth, the vacuum.
No uniform vacuum. Empty space isn't inert. It must carry a structure of microfractions. If vacuum energy, like the Casimir effect, is the same in cavities with different symmetries, hex versus phi match size, then the vacuum isn't structured as predicted.
And lastly, consciousness again.
No consciousness without self-reference across scales. A simple, non-recursive system won't be aware. If you build complex, multi-scale, recursively referencing systems and they don't show new, emergent, stable self-states, then the proposed mechanism for consciousness is wrong.
Okay, those are the lines in the sand. What about the positive predictions? What should we see if this is right?
This is the exciting part. First, phase beats amplitude in shaping. This means if you keep the total energy the same, but only change the phase program switch between half or rhythms, you will change the resulting shape or structure in, say, living tissue. Half gives polarity, or gives hex patterns, or it gives spirals. Phase alone should be the switch.
Second prediction.
Geometry gates vacuum energy. The Casimir force, the vacuum energy between plates, will be different depending on the symmetry of the plates, hexagonal versus decagonal versus parallel, even if the area and gap are identical. Geometry shapes the vacuum itself.
Third.
Quasicrystal and fan pattern surfaces harvest better. Surfaces structured with non-repeating spirals or quasicrystal patterns will be better at converting ambient noise, heat EM fields, into usable electricity than simple flat or hexagonal surfaces of the same material. Geometry enhances energy harvesting.
Fourth, back to quantum.
Collapse follows nodes. In a double-slit experiment, if you subtly alter the boundary symmetry around the slits using phase fields, say imposing U versus O symmetry, without changing the number of particles, the pattern they make on the screen must change predictably. We should be able to steer quantum outcomes of the geometry.
Fifth, on a huge scale.
Orbital and weather Fecus lock-ins. We should find persistent polygonal storms, 4, 6, 10 sides, in rotating atmospheres like Jupiter's or exoplanets, and see hexagonal domains edged by spirals and galaxy halos. These fractions should sculpt cosmic structures.
Sixth,
Water coherence is fraction selective. Carefully prepared water exposed to phase programs encoding patterns should show longer-lasting internal coherence, more stable structures than water exposed to hex or random programs at the same energy level. Water structure should respond to these phase codes.
and seventh, machine consciousness.
Recursive fields yield machine cell states. If you build systems of coupled oscillators with internal feedback loops allowing self-reference, they will spontaneously settle into new, stable, complex patterns, self-states, that weren't present in the individual parts. This shows a pathway to emergent complexity, potentially awareness.
Those are some very specific, very testable predictions across many fields.
Yeah.
What about the math? Can we get a feel for how fractions make geometry without calculus?
We can try. Think of a fraction of time as just taking a specific angular step around a circle, again and again.
Okay.
Let's say the angle is alpha. We take a step, put a dot, take another step, put another dot.
Okay.
Now map those dots onto a 3D sphere. If your angle alpha is the golden angle related to highly irrational,
You get the Fibonacci lattice, like on a pine cone.
exactly. Near perfectly uniform distribution, minimal crowding, that's why Fibonacci numbers, 1, 2, 3, 5, and 8, pop up. They describe the spirals formed by this most efficient irrational packing.
And if alpha is a simple fraction, PPQ.
Then the dots line up neatly into Q bands, creating Q-fold symmetry. A half fraction gives 2 bands, like polarity. OU gives 3 or 6-fold symmetry, hexagons. OR gives 5 or 10-fold patterns and spirals. The fraction directly dictates the resulting geometry spread out or locked onto rails.
Does this work in 4D too?
Yes, the math extends using something called a Hopf vibration. You use 2 irrational angles, alpha and beta. If they're incommensurate, you get a beautifully spread out 4D pattern like superposition, potential everywhere.
And if alpha and beta are rational,
It locks the 4D space onto specific torus links, discrete rails. Information condenses. Making a measurement, imposing a cut, forces the system onto one of these rails, reminiscent of quantum collapse.
so the choice of fraction, rational or irrational, fundamentally determines how information and energy distribute uniform spread or discrete symmetry.
That's the core mathematical engine driving the geometry.
And it all boils down to that one equation, E equals mc way.
That's the compact summary. Mass m is trapped time-fold energy, c is the speed limit of smooth time, and d is the crucial geometric multiplier determined by the specific fraction governing the structure.
And the key is that E isn't always 1. Geometry matters for energy yield.
If b was always 1, if geometry didn't multiply the energy potential of mass, the theory loses its main leverage.
Okay, for the deep skeptics, what are the absolute minimal make-or-break experiments? The minimal falsifier set.
3 core tests are proposed. First, the living monolayer test. Grow a flat sheet of cells, give it constant energy, but switch the phase program driving its environment, half, whole, and random. If the morphology, shape, pattern doesn't switch predictably, polarity, hex order, spirals, the core claim is wrong. Phase must dictate form at constant energy.
Second.
The Casimir cavity test. Measure the vacuum force between plates. Use 3 setups. Identical gap in area, but different symmetry parallel, hexagonal, decagonal, related. If the force and energy spectrum are identical in all 3, then the vacuum isn't structured by geometry as claimed, and the theory is wrong. Symmetry must affect the vacuum.
And third.
The thin colloid test. Use a thin liquid suspension, drive it with the same phase programs at constant energy. If hex order doesn't appear under O or decagonal spiral patterns under O&CO, and you can't switch between them just by changing the phase program, then the claim that geometry arises directly from phase is wrong.
If those 3 tests pass,
Then this framework moves from intriguing theory to potentially transformative science. The leverage point shifts from just adding energy to tuning phase in geometry.
wow. Okay, what an incredible deep dive. We've gone from a simple leaf.
All the way to a theory suggesting the universe is this dynamic dance of times, folds, and fractions.
We've seen geometry as an active engine, not just a container.
We've touched on quantum mysteries potentially resolving into geometric cuts.
And even consciousness framed as a kind of self-referential folding, a resonance.
It really does challenge you to rethink the fundamentals.
Absolutely. And if these predictions start getting confirmed, the implications are enormous. Shaping reality might become less about brute force.
And more about understanding and tuning these fundamental fractional phases of time itself. Precision over power.
So a final thought for everyone listening, something to ponder from the source material. We are the empty space inside the boundaries of boundless time. The silence made audible, the void made visible.
It suggests we're not just the matter, the boundaries, but the dynamic, coherent potential held within. We are living pockets of this universal score.
A unique song within the grand symphony. What will you choose to explore first with this perspective? We hope this deep dive has given you not just information, but maybe a whole new way to hear the music of the universe.